Yo, what is up, everybody? This is Cushion Tech here, and today I'm gonna be talking to you guys about do computer science students need physics? The answer is it depends on what are you planning on doing with your computer science degree. It depends. Physics is not a required course for all computer science program in different universities. Like for instance, my university does not require physics. It doesn't require physics, but it can be very beneficial and it can help you in so many things, though. But it's not a requirement for most CS programs. Like it can be beneficial in certain areas. Like if you want to go into physical or hands-on, physics is let's see better is good. Let's see, most computer science students do not take physics classes unless if they're interested in it for some reason, or unless if they want to go hands-on or into really nice thing, hands-on or hard fields. All right, let's begin. Computer science students need physics if they plan on going into game development, because many game development engines such as Unity and Unreal Engine has physics attributes such physics tools and physics, let's see, physics things, different physics things, because they need to include physics in their objects, physics in their objects and all that, their dimensions. Unity also helps you stimulate physics for your let's see, projects like collisions in the Unity game develop packet. It helps you with rigid body dynamics, the movement of interaction of solid and flexible objects, like is objects objects. It deals with the effects of gravity, elasticity, sounds, and interaction of lights with objects. Computer science students need physics if they plan on going into artificial intelligence, because artificial intelligence requires so much math, logic, and problem solving skills. They require math, logic, and problem solving skills. And problem solving skills. Problem solving skills. It leverages it let's see, artificial intelligence uses physics principles to model and stimulate systems, helping machines learn and make decisions. They also leverage machine learning algorithms to simulate, predict, and optimize physical phenomena. Let's see, let's see, let's see. Physics is really important, because quantum states, we need to do quantum states and all that. They're AI powered physics tools. Let's see, computer science students need physics if they plan on going into hardware or any hands-on, because hardware works with the electricity, the circuit boards of the computer, and you need to learn about electricity and magnetism, how electricity flow, and in that we have to learn in that yeah, and by learning physics we learn how electricity flows and how electricity, let's see, flows and all that. We have to go into hardware, and we have to go into if we plan on going into hardware, we have to learn how electricity flows within a current and all that. And we also have to learn how let's see, we hardware works with circuit boards, and circuit boards work with electricity, so we have to learn with physics and all that. We have to learn with physics and all that. physics. You need physics if you plan on going into or working in software engineering, because like it can be helpful and provide valuable insights into system behaviors and performances, because electric circuit signal processing and thermodynamics can be used to developing various software solutions such as embedded systems and scientific simulations. In physics, there's physics principles such as motion, energy, and forces are applied into certain area of software engineering. There are physics-based simulations and animations that are used in software engineering. Let's see, physics. Many of the computer science concepts are solely based on principles of physics such as thermodynamics, electromagnetism, and quantum mechanics. You may need some physics if you plan on going into data engineering, because you're gonna be like engineering like data, and any form of engineering requires certain physics, and like requires physics and any other like form of let's see, engineering. Let's see, physics, because like you're gonna be applying physics formulas and physics, let's see, things to like data and all of that, because like it helps you respect data, and like it helps you analyze data and engine and create new data. If you plan on you'll definitely need physics if you plan on going into computer architecture, because like many computer architectures require to learn electricity, and like if you want to learn electricity, it's better to learn physics, because like physics, let's see, has like because like physics, you'll learn how electricity flows from one circuit to the other in physics, and like if you go into computer architecture and all that, like you're gonna have to learn about how much power it uses, like how many like Ohm's law and all that, and like Ohm's law is like a physics formula and all that. Let's see, physics and all that, and you're gonna have to learn the anatomy of a computer, like and of a computer and all that, like you need to learn like basic laws with quantum physics. Let's see, quantum physics and all that. If for developers or like computer science students who want to improve their coding logic or any of their logic, the physics is like logic physics. They could take physics, because physics requires so much logic, and like so much logic, and like so much logic, and like logic and like by practicing more physics problems and doing more math and physics, doing physics project problems, it'll improve your logic that you need for computer programming and all that. It'll not only help, it helps your logic, like doing like so many physics problems on top of memorization, and applying these like physics concepts to these logics, and like it also improves your logic in a very wide variety of ways. If physics is needed if they want to go into research, because like physics, let's see, is not only in resource. Physics is needed if they want to go into research, because if they want to go into hands-on materials or like learn new things, they're gonna have to learn physics, because is let's see physics is needed to stimulate is used to simulate new computer science topics. One of my professors in college told me that if I should take physics if I plan on going into like research and all that. If I plan on going into research. because like physics is a because there's computational physics that may be used like during research to research new methods about like solving computer science projects, complex problems to complex problems and development of computer systems and the simulation of physics phenomena. Let's see, if developers want to improve their math skills or get better at math, they need to improve, they need to do physics, and physics requires so many math and is heavy, and like the more physics problems you practice, the more math problems you'll get better at. And like, let's see, the more physics problems you'll encounter, the better math skills you'll get, and the better the math skills you get, the better programmer you will become. Let's see, if they physics is needed for people who wants to go into scientific computing, because like if many because like, let's see, scientific computing requires physics, so much physics, and like and scientific commuting also requires, like, let's see, physics in a variety of ways, such as like, let's see, like the application of physics in computer systems and the simulation of the physics phenomena. In the physics phenomena. And the physics phenomena, it also requires the use of computer science physics and a variety of physics. Let's see, physics isn't needed if you plan on going into web development, because in web development you're just writing HTML code to write the structure of a website, and CSS to write the coloring of the website, and the JavaScript to write the brains of the website, and like to like display, you're just only displaying certain things with JavaScript, and like you're also using JavaScript to fetch data from the API, or like your own databases you created, and all that. Like you're also, let's see, using the backend such as Python to send data from your database to the front end of the user, and to the front end of the user, and like, let's see, you and like in web development, like you're using Python or Java, or to send data you're trying to extract data from the database and send it to the front end. And like, if you don't really need to go into web development, if you also want to need to go into web development, you don't really need physics, because like you're just mostly like designing the website, and like you're like, let's see, trying to get display info on the website. Physics is barely used in cybersecurity. You don't really need physics if you're going into cybersecurity, because physics isn't really used in cybersecurity. Cybersecurity is more about like developing algorithms and developing algorithms that provide secure communication between one group and another group, and it's more about preventing hackers, and like hackers from getting information. It's more about preventing, like, let's see, cyber attacks, and there's no like physics used. There's no like physics used in cybersecurity when developing like secure algorithms. And like, let's see, it protects computer systems and networks from attacks rather than developing. It doesn't really develop, it just protects. it just like creates algorithms and it doesn't develop actual like products. It develops like algorithms and solutions and like protection devices and protection software to protect, let's see, from any attacks or like hackers. And like cybersecurity is mostly used for is not doesn't use physics at all. It just protects uses to protect the like software, and it uses to protect computer systems and networks from attackers. Let's see. Let's see. Computer science students don't really need physics if they plan on going into info systems, because information systems it's about like gathering, analyzing, maintaining, or distributing or managing data within a computer, or like within like a computer system, within like software or databases or networks that are like mostly for like business purposes only. Like let's see, create like information systems they just like develop or like create systems only for like business purposes. And like let's see, like and like data like tools such as laptops, databases, networks, and smartphones are examples of databases. Let's see, like because like many people who are because information system like uses technology and develops and like uses code to create business applications, and there's no physics used in information systems. You use data and technology to help a nonprofit, to help like anything in an excited way. You help plan things, become a technology entrepreneur. It designs it helps businesses use technology to be more efficient, transparent, and secure, and makes services more accessible, and like it designs, delivers, and uses information and data and communication to solve problems for like uh, businesses and all that. Businesses, it's like managing information. Like let's see, it like collects, stores, and processes data among businesses and other things. Let's see, and also like let's see, like it shows people how to use technology, manage information, and like let's see, many of like the people who work in management information use computer-based tools, softwares to collect, process, store, and distribute. And they even develop some software depending on like how your experience in management information systems. But like there's no physics used because they're just only creating software for a bit that businesses need to use for gathering data. For computer science students who go into business analytics, they don't need physics for business analytics, because like they're using data to improve business decisions by like analyzing like old business performance and identifying trends and patterns. They like let's see, transform data into insights and improve business decisions, like data management, data visualization, predictive modeling, data mining, forecast simulation, and optimization, which used to create data. There's no physics used in business analytics. Let's see, business analytics are just analyzing data or like analyzing things, because they use data to make better decisions for businesses. It prepares students to analyze and create strategies to improve customer satisfaction and revenue. They use data to like they like even develop new data modules, like analytic modules, like experience needed to create. Like sometimes business analytics requires students to develop, let's see, software to manage data, or to like let's see, analyze data quickly. Let's see, computer science students don't need physics if they plan on going into data science, because like data science, let's see, only let's see like ex- studies data and extracts full meanings insight for businesses and other things. It uses statistics, and the statistics, it does not require any form of physics to implement algorithms. Like it uses data analysis, it uses informatics, it uses statistics and variety of other tools needed for data science and all that. And like data science is also like, let's see, used for a wide variety of things. Data science barely uses physics, and like data science doesn't use physics at all. They use only computers and all that. Let's see. For computer science students who plan on going into data analytics, they don't have to learn physics, because like physics is barely used in data analytics and all that. And data analytics, they just only analyze the data, and like they only analyze the data for like certain things and all that. Like they only analyze data to like do variety of things, a wide variety of things and all that. That they only analyze data to do certain things. They only analyze data to do. They only analyze data to do like for business purposes. They analyze data. They only analyze data. They do data analytics to like perform like business tasks to improve businesses. They only use statistics. They don't use physics. Let's see, computer science students don't need physics if they plan on going into database management, because in database management they, let's see, only organize, store, and retrieve data from a database. They also protect data, prevent legal and compliance risks, ensure data-driven applications perform well. Database management is important for businesses because the data can be used to make strategic business decisions, improve market campaigns, optimize business operations, automate processes, ensure adequate performance queries, keep up consumers' demands, and like data archiving, replication, masking, retirement. Like, let's see, database management use software systems to use store, retrieve, and run queried database is not physics are not really used in databases. Databases more about like inserting data into a database, and like into a database and all that. They don't really use physics, and like, let's see, they just create databases to like, let's see, create databases between, and let's see, APIs. They use database they fetch use APIs, where like the back end fetches data from the database, and then sends it to the front end. Let's see, computer science students don't need physics if they go into database administration, because database administration manages database management software, and they're responsible for ensuring databases run efficiently, and they're not required for developing like any new databases or anything, so they don't really need physics for it. Let's see, they make sure the databases run efficiently and the data is stored and retrieved. Databases often work with developers to design and implement new features or troubleshoot any issues, and like they ensure that all databases run efficiently. Let's see, they create and organize systems to store a variety of data, such as financial information, customer shipping record. Database administration manages computer databases, like capacity planning, installation, security, troubleshooting, data recovery, and all that. It manages data repositories, resolving data conflicts, plans development, and organizes enterprise data model, implements data policies, procedures, and standards. Let's see. Computer science students don't need physics if they plan on going into computer graphics, because computer graphics is basically like art, except you're writing code that draws the art for you. You're writing code, implementing solution, and implementing your own logic to draw the art for you, rather than just hand drawing the code, or rather than using Photoshop or any form of like photo editor. Like, let's see, computer graphics, you write code that writes the art for you. Like, for example, like there are like so many libraries and like modules that can write art for you and like design for you and like write a variety of code for you and all that and if you plan on going into computer graphics and let's see, if you plan on going into computer graphic, then computer science is good for you. Then you don't need